Hi, welcome to an Arduino tutorial from Robojax. My name is Ahmad Shamshiri, presenting this tutorial from Canada. In this tutorial, we are going to learn how we can control the speed of motor with temperature sensors DHT11, DHT22 or DHT21 using L298N module, which I have written library for. Speed of motor will increase as the temperature increases, and the speed of motor will decrease as the temperature decreases. And as you can see here, 42 degrees and 38%. If I heat this up, close it. You can get the code for this by clicking at the link below the video in the description, which will take you to robojax.com/learn/Arduino. Let's get started with this. I saw a lot of interest in controlling speed of motor with temperature from the comments and from Facebook messages. In this video, we're going to control the speed of motor with temperature. As the temperature increases, the speed of motor will increase and the temperature will decrease. The motor speed will decrease and it will stop at the minimum value that you set for the stop and the minimum value that you set for temperature. This code will work for DHT11 or DHT22 and DHT21, and the library and code will be available. I'll provide you the link for that. I'm using L298N to control the motor. This is one of the best modules that you can control two DC motors because it has heatsink, small heatsink. That's enough for our application. I've written library for this, so this can be used easily to control one motor or two DC motors. I have separate video explaining everything. Make sure to watch that before coming to this. I will provide you the link. You will watch it, you will download and install the library. Make sure that you can control one DC motor with this, and once you are successful, then I will provide you the link that you have to use either DHT11 or DHT22, whichever you have. And make sure to download the library and make sure that you can read the temperature on the screen before coming here. Then here it has been combined, both of these together. Here, for example, you set a minimum temperature for temperature, let's say 35 degrees, and at 35 your motor will start activating, and your maximum is 60, and above 60 your motor should continuously run. So for example, this is a fan cooler, and if the temperature increases above 35, you can set the value, so the fan will run. When the temperature reaches below this, the fan will stop. But as the temperature increases, we want also the motor speed to increase. For example, you set the minimum at 30% and the maximum at 100%. So we control the speed of motor, and here is a combination of both. Let's say at 35 degrees, you want the motor to be at 30%, and as the temperature increases to, let's say, 60 degrees, the motor must reach 100%, and if it goes above that, it's okay, the motor will continuously at 100%. So this is how we implement this in this tutorial. Let me now explain the wiring, quickly explain it. We have two wires. This goes to my battery or my power supply. You can connect with 6 to 35 volts here. The left side is positive, goes to the battery. This goes to the ground of the battery or negative, so 35 volts come. And we have voltage regulator here, which outputs also 5 volts in case if you want to power your Arduino when it's disconnected. And also the middle pin, there is also a ground. I have used this gray, which is connected here to ground of Arduino. And my motor 1 will be connected here. This is my motor. And you can connect larger motors depending on the amount of current that you draw. I've explained this in the introduction to this module. And once you disconnect it from power, this wire from this point, this wire, the last pin, will output 5 volts. You can connect it here to VN or to 5 volts. In both cases, it will work and it will power it up. And here for the motor wires, enable A is connected using orange wire to pin 3. This is pulse width modulation. You see this tilde, this This pin must be connected to Arduino's pin that has this tilde. These are pulse width modulation enabled pin, which we control the speed. Otherwise it will not work with you if you connect it to other pins. N1 is connected using red wire to pin 2, and N2 is connected using brown wire to pin 4. For my temperature sensor, this is the data pin connected to pin 6, and yellow is VCC connected. Yellow is ground, has been connected to ground, and this has been connected to 3.3 volts or 5 volts. 3 wires can be connected either to this module or this module. Here it has been labeled as positive, negative, and the middle one is out, and here it has been labeled as ground, VCC, and data. So data is out, and ground is this negative, and VCC is this positive. So whichever you have, you just plug it in. Now let me explain the code. As I've explained at the beginning, you need to watch my other video, introduction of to L298N DC motor controller. I've used the library, so I assume that you already have installed it. So this is part of the library. If not, please download it from the provided link, but you will be lost if you do not watch the video, because there is a lot of explanation on how this works. Pin 2, pin 4 will be assigned to N1 and N2, and pin 3 for enable A. This is for one motor. And in the same video, I've explained how to control 2 motors in case if you want to use it. And then we are defining a variable CW, CCW, 2 and 1, and then we are defining motor direction. You cannot change this, but here you can change CW or put CCW. This will make your motor to rotate in your desired direction. And then because we are using one motor, defining motor 1. As I said here, do not change, so you do not change this. And then from the class that we included above, we create an object, an instance of the object. We call it motor, and we pass this motor and enable pin in here, N1, N2, and enable. And as I've explained in the code, if you want the debugging information or speed of motor, and it will display the debugging information. If you don't want it, just remove it. It will be waste of resources in case if you don't need it. Then these are the most important variables that you need to set. Temperature minimum, the minimum temperature that you want to operate. This is, for example, 40 degrees Celsius. If you're using Fahrenheit, still it will work, but I'm going to show you later on how to measure Fahrenheit. So you set your value, and this is the speed of your motor in percent, 30%, because some motor will start at 20% of the power from motor controller. So you will find out, either set it 0 or set your desired value, and maximum temperature is another variable that you set. For example, after this value, after this temperature, you want motor to run at 100%. So set some temperature, and you say anything above this should be 100. So this is your maximum, and this is the speed of motor. Sometimes you don't want motor to run above certain value. Let's say you don't want your motor to run more than 80% of the speed, set 80. So your maximum will be set here. And then this is a variable that is used internally. Do not change this. And these are for the DHT library. As I mentioned, you have to also include this library. Watch the video for this, so you make sure that you can read the temperature. And we are defining a pin 6 for the DHT pin. And when you're using DHT11, uncomment this and comment it like this. Now this will work for DHT11. And if you're using DHT22, uncomment this one. And if you're using DHT11, the same way, uncomment the other one. And from this class, we are creating an instance of the class, call it DHT with lowercase. And we are passing this value here and the type in here. So this will initialize the temperature sensor for us. Inside the setup, we initialize the serial monitor with 9600 baud. This is the value that when you click on tools serial monitor, this will pop up and it will show the temperature. And here on the right side at the lower, you will see if you do not set that properly, for example, if you set it for something else, you will not be able to read the text properly. Either it disappears or you will read something unusual on the screen, like special characters like that. So you have to set it at 9600 baud, and when you set this 9600, it must match this value, and these are just the text and line. And motor.begin will initialize the motor with those pens, and DHT.begin initializes the temperature sensor. The setup is done now. Inside the loop, temperature to speed, this is where we convert the temperature to speed of motor, which I will explain next. This is a separate function at the lower portion of this code, and this is just printing motor speed with this value for us. So we can read it. This demonstration that I've explained in the main code, if you want to test your motor with different values, just uncomment this, and it will do a lot of tests of your motor, clockwise, counterclockwise, different speed, brake, and all those. So I have commented out. It's not working at the moment. If you want it, just do it. And then motor.rotate is where we control the motor. We are controlling motor 1. We are passing the speed, and we are passing the direction. So these are all have been defined at the beginning of the code. I explained them. This 3 seconds is very long. It was just a coincidence. So you don't want to do that. We will have to put it maybe 500 milliseconds or even 0 if you want very fast reaction of the motor to react with the temperature as the temperature changes. This is the internal code for the motor driver, for motor library to brake, to apply brake. And this is end of the loop, and the loop will continuously execute all these codes that we have. Now, temp speed test, temperature to speed, is a function that before the motor is running, this will go and convert it so the motor can run properly. And temperature to speed, here DHT.read temperature will read the temperature in Celsius. I put it here, and then we store this in this variable of type float. We call it T, temperature. And if you need Fahrenheit, comment this out like that, and comment this line. These two lines are exactly the same, except we have here true. When you have true here, this will return Fahrenheit. So this T will be now Fahrenheit. So I'm commenting this out because I'm working with Celsius. And then the temperature, the value, and here is, if you want to put it as Fahrenheit, change this to F. And here this map, this is the most important portion. It gets the temperature, whatever it is, Fahrenheit or Celsius, and the value, the map is mapping from minimum value that you set at the top to the maximum temperature. This is minimum and maximum. These are the value that it gets. It maps it to the minimum and maximum of speed. Let's say if this is 40 degrees, the speed will be 30. Let me show you. You see, if this is minimum temperature, and that's minimum speed, and maximum speed, maximum temperature, maximum speed. So this will map it automatically. It does a calculation, and the result of a calculation is stored in the motor speed, which we have defined at the top of the code. So this updates it in here. And this line is just fixing a value if the temperature minimum is smaller than T. Let's say you set this 40 degrees and the temperature goes 20 degrees. In that case, because it's lower, then we set the motor speed to equal 0, and motor.brake1 will apply brake, so motor is stopped. Because sometimes the temperature go below the value, so this code is needed. And also, if the temperature is above the maximum, we also set the motor speed to 100. This function is executed inside the loop continuously. Now let me demonstrate it on temperature at 40 degrees and the minimum speed of motor at 30%, and the temperature maximum is set at 65, which means above 65 the motor will continuously run at 100%. So that's the maximum speed, but also you can set your maximum, let's say at 65 degrees, which is your maximum temperature. You want the motor to go 90%, so you can set your value here, the minimum and maximum for the motor, and also the minimum and maximum for temperature. The serial monitor is now open. Currently the temperature is 35 degrees because I heated up a minute ago. and I put here a candle, and this is my motor. I could use also a smaller motor like this, which I'm going to do next. And this is the L298N module. I've not connected my power supply yet. Let me connect the power supply. Now the power is up, as you can see here. This light, the light is on, and the temperature is 33 degrees. I will hold this above this, making sure it doesn't burn. So let's see here, the temperature is 32 degrees. I will close it. I'll bring it closer so the temperature increases. Now 35. Let me hold this with the motor now. Temperature is decreasing, the speed is also decreasing, and less than 40 it will stop. And here is a demonstration with smaller motor. This is the motor that is this motor, and smart car people are using them. As you can see, the temperature is showing to be 26 degrees, and the speed is 0 because it's below 40. And now I'm heating this up, getting it here. There is some distance in between. So let me get it closer so the temperature increases. We'll start rotating. %, almost going to stop now. Just below 40, and the motor stopped. Now I've connected DHT22. The temperature shows 25 degrees. Let me hold it closer so the motor will start rotating quickly. So you see 39.1 degrees. We'll get let's see the speed. As you can see, it's going slow at 35%, almost going to now stop. As soon as it gets below 40, this will stop. Now I'm going to use this heat gun to heat it up very quickly. You pay attention to the temperature and speed here. Even if I apply and make it more than 65, which is our limit, the motor will continuously run at 100%. As you can see, it's 77 degrees. 86 degrees and motor is at 100% speed. Thank you for watching. This was how to control the speed of motor with temperature sensor. I will have a lot of other videos for different temperature sensors to control the speed of motor. Make sure to subscribe so you get updates once those videos are uploaded. If you like this video and learned something, please thumb up, as this will help my video in the search algorithm of YouTube. If you have comment or question, post it at the comment section below. I try to answer and reply. If you want to get updates of my upcoming videos, make sure to subscribe. Hey Baba, hey Baba.